Hi students, in this video we are going to solve problems related to sets. The question is, give an example of two sets A and B such that P of A union P of B is not equal to P of A union B. Here P of A means it is a set which contains all possible subsets of set A, and P of B means it is a set which contains all possible subsets of set B, and we should prove that the union of these two sets is not equal to all possible subsets of A union B. We will solve this problem. We assume that A is a set which contains only one element, that is 1, and B is another set which contains only one element, that is 2. Based on these two, we can say A union B is 1, 2, because A union B means all the elements in set A and all the elements in set B will be the part of this set, and repetition of the elements is not allowed. Based on the given information, we need to find out what is P of A, P of B, and then we need to find out P of A union B and then P of A union B. We need to check whether they are equal or not, but we are expected to prove that they are not equal. Hence, based on this set, we can write all possible subsets of A, that is P of A is equal to a set which contains this element 1 apart from that pi set, because pi is the subset of all the sets. So this set A can has only two subsets. Hence P of A contains only two sets. Next, B. Now we are expected to list down all the subsets of B. Pi is one set and the set itself is a subset. There is no other subsets for this set P. Hence P of B is equal to pi, 2. I hope you understand this. Now we are expected to write P of A union P of B. We have P of A here, P of B. When we write it in the union form, all the elements present in this P of A and all the elements present in P of B will be written, but repetition is not allowed. Hence P of A union P of B will be equal to pi, this set 1 and this 2, the set 2. These are the elements of P of A union P of B. Now we calculated left hand side and then we need to calculate right hand side. In the right hand side we need to write all subsets of A union B. Here A union B contains two elements 1, 2. Using this we need to find out all the subsets of A union B, that is P of A union B. We know that null set, that is pi is the subset of all the sets, and then using this 1 we can create one set, and using this 2 alone we can create another set, and we know that the set itself is the subset of itself. Hence the set contains 1, 2. Hence P of A union B, that is all possible subsets of A union B, contains 4 elements. Now we need to check whether these two are same or not. P of A union P of B is equal to P of A union B or not. If you look at this, here 1, 2 presents in this, but here it is not present. Hence both of them are not equal. Hence we proved this sum. Next we move on to another question. The question is, if A union B is equal to A intersection B, then prove that A is equal to B. Here it is the given information. The given information says that A union B is equal to A intersection B. As using this statement, we need to prove that A, B. Here we will take first left hand side, we will work on this, and then we will take right hand side, we will work on it. Finally we will check whether A is equal to B or not. Actually we must prove that A is equal to B. So what we do is we will take the left hand side and we will solve it. First we will take an example. Let us assume that small x is a part of the set A. Hence we can say that when x is the part of set A, that is x is the element of set A, means definitely x must be part of A union B, because when we write A union B, we write all the elements of A and all the elements of B, but repetition is not allowed. Hence when we say that X belongs to set A, it means that X belongs to A union B. It is given that A union B is equal to A intersection B. Hence, X belongs to A intersect B as well, because both of them are equal. From this statement, what we can identify is when X belongs to A intersection B means X is the element which present in both the sets, meaning X is the common element in set A and set B, because A intersection B means we write down all common elements which are present in A as well as set B. Hence, X must be a part of the part of the set A, and X is also the part of set B. When X belongs to A and X belongs to B, definitely we can say that X belongs to B also, right? From which we can say that since X belongs to A, we can say that in this place we can put A. A is the subset of B. I hope you understand this. Now we have taken left hand side. In the left hand side we have taken one element using which we proved that A is the subset of B. In the right hand side, what we need to prove is here A is the subset of B. B is the superset, A is the subset. In the right hand side, in case if we bring B is the subset of A, that is A comes here, B goes here, like that if we prove, that means we can say A is equal to B. So we are taking one element Y which belongs to B. When Y belongs to B, definitely this element Y must be the part of A union B, because as you know very well, when the element present in one particular set means when we write A union B, union form means all the elements in set A and all the elements in set B must be the part of A union B, and repetition should not be allowed. Hence, Y should be the part of A union B. When Y is the part of A union B, as per the given information, Y also belongs to A intersection B. When Y belongs to A intersection B means Y must be part of A and Y must be part of B, because in A intersection B we will write down only common elements. Hence, Y belongs to A and Y belongs to B. So based on this statement, we can say that Y belongs to A. In this place of Y, we can substitute B. Hence, B is the subset of A. Here if you look at it, A is the subset of B, and here if you look at it, B is the subset of A. Hence, both of them are equal. I hope you understand this theoretical explanation. These types of problems in sets are very important because they are like theorems. I hope you understand these two problems clearly. Thank you students. Thanks for your cooperation.